Hi guys, welcome back again. Sorry for the low volume here. Everyone else is asleep in my house, so I gotta record quietly today. But just wanted to go over our random assignment activity for the discussion this week. So what I did is I recorded all you guys' results from our Padlet, and I just counted how many moons were on the left, how many A moons were to the left of the center line, and then similarly how many moons were above. So let's walk through the assignment together first. Okay, so if you recall, we had the plots of land, right? And then we had the trees on the left of the river, and the top had a bunch of trees. And then, I forget if we talked about this last time, but the experiment itself, the experimental units, here's a hint. Treatments are assigned to the experimental units. So what are the experimental units here? Those would be actually the plots of land. And that's where you have like the A or B or whatever, yeah? And what is the treatment? The treatment for us would be planting at different moon phases, right? Whereas Kupa or something else, referring to our discussion three. Okay, so question two, why do you think it's important to randomly assign moon phases to the plots? And would it have been a good idea to use moon phases A on the eight plots on the left? So let's say I put all my A's on the left. So that would not be random, right? That would be some kind of very systematic way. Why is that not a good idea? The reason why that's not a good idea is because maybe the trees in the river has some effect on the outcome, right? So like maybe that land is extra fertile for some reason or something like that. Or maybe it has actually a negative impact. Either way, it's affecting the outcome. It's you're introducing some confounding variable. So assigning on the left would not be a good idea. Similarly, you wouldn't want to assign it on the top either, or anything that's not random for that matter. So we avoid that by doing it random. Okay, and then last week we did all this, right? And we all read our own random assignments. We shared with everybody, and so I compiled everything, and we're about to reveal the results. So here we go. Where is it? Here, yeah, here. Okay, so first, left and right. Let's see if I can zoom in one at a time. So we'll just do left and right, okay? Actually, let's just do it together. So left and right, and then above and below. Here I have all the individual counts and the totals at the bottom. So here's the total of number of A's that appeared to the left of center and the total that appeared right of center. And what do you notice, guys, about these? Do you notice that these numbers are almost exactly the same? Isn't that crazy? And this is not like, predetermining or putting any restriction on where those A's or B's would go, but just by count, we have exactly 191 on the left and 193 on the right. So super close numbers for A's on the left and right. And by the way, this also means if there's 191 on the left, that would mean there would be 191 B's on the right, right? And then similarly, 193 A's on the right means 193 B's on the left. So we really only need to pay attention to the A's. B's are going to fill in the gaps. So the answer here would be 191 and then 193. And then we do the same thing for above and below. So the above and below, the count came out, actually a little further apart. And this outcome, to be honest with you, was not what I was exactly expecting. This is a little bit unusual. And if I look at my results here, we sort of just got unlucky because let me highlight all the instances where the left was bigger than the right. So it kind of had like I'm sorry, the top was bigger than the bottom. So looking at that, I have like just a lot of unlucky streaks where I have a lot more on the top than on the bottom. And then if you compare that to the instances when I had fewer on the top compared to the bottom, that turned out to be just a lot less. And that's just kind of random, just a little unlucky here. But you know what would sort of rectify the situation is just increasing our sample size. Now, even though that's all said, check this out. Even though I said we have an unlucky result and we're looking a little bit bad, 178 minus, oh sorry, 206 minus 178 is a difference of 28. Now 28, that's out of a total of how many A's? So I have 28 out of 206 plus 178 is 384. So out of 384, I got 28 more. And what is 28 out of 384? Oh, that's about 7%. About 7% is of my overall A count is that's how much more is on the left. So that's like, if you think about it, even though it's sort of an unlucky result, they still ended up relatively close together. But this one was a really nice outcome where they're very close. Or just for comparison, I'll show you guys last year, my class last year. So left and right, I had 102 versus 98, and up and down, it actually reversed at 98 versus 102. So this is another very close result. And this is with a smaller class, because this year I have two sections, and we just compiled all the information. Okay, so let's get back to what does all this mean? So question number three, did your random assignment result in approximately even split left and right? What about above and below? Left and right for sure, I'd say approximately equal. Above and below, I'd say reasonably close to even split, yeah. Okay, now for an experiment, random assignment is used as a way of ensuring that the groups that receive each treatment are much alike as possible with respect to other factors that might affect the response. Explain what this means in the context of this experiment. So in the context of this experiment, looking alike as possible, you're not considering the treatment, alike as possible is position relative to these outside factors of the trees in the river or the trees at the top. And the big thing that I want to point out to you guys is that when we do random assignment, we did that random assignment completely blind to this. Like knowing the knowledge of these trees on the left or the top played no factor into how we chose our A's and B's, right? We just randomly assigned them. But what do we notice about that? Even though we randomly assigned it, we ended up with pretty fair treatment for left and right and pretty fair treatment for top and bottom. So by randomly assigning things, what that means is we're accounting for confounding variables that are sometimes unseen. So there might be a confounding variable that we're not even aware of, but by randomly assigning, we're actually accounting for that to make a fair experiment. Now, we could have also, split up our designations based on the position and done like a sort of modified random assignment. But just by pure random assignment, we're accounting for. And I actually think random assignment is better in this case because these are only the visible variables, right? But like what if I said, okay, I'm gonna account for the left and right, but then unbeknownst to me, there's like a sinkhole or something, or like some other like there's like a fire in the land or something, and I ended up putting all my A's in one spot there for some, just by chance. So by randomly assigning my fields, I would have accounted for that as well. So anything that some issue that I maybe not even be aware of, random assignment is gonna deal with that for me. Okay, so that was question four. Yeah, question five. Suppose at the end of the experiment, the mean yield for one of the moon phases is quite a bit higher than the mean yield for the other moon phase. Explain why it would be reasonable to say that the moon phase is the cause of the difference and not the proximity to the river. So, or the northern tree. So we can say that it's probably the moon phase and not those things because we have an approximately sorry, not evil, equal split, right? So it is approximately the same. It's basically fair for top and bottom or left and right. Now I know it's not totally fair because it just so happened we had a kind of a unlucky mix, but again, as you increase the sample size, this difference should also overall decrease. Like the percentage difference is going to overall decrease typically. Okay, guys, that's all I have for debrief. So for our discussion this week, you can go ahead and answer the questions with all those things in mind that we just talked about. Right? Have a great one, guys.